Matrix is a two-dimensional array organized by rows and columns. Visually speaking, you can think of a matrix as a table filled with numbers. For example, the iris dataset can be viewed as a data matrix. Each row in the dataset represents one iris flower sample. The first four columns are its features: sepal length, sepal width, petal length, and petal width. The final column shows its species. Using matrices as tables is just the beginning. Their real power lies in linear transformations. We'll dive deeper into linear transformations in future videos. As we mentioned before, a row vector is a matrix with one row and multiple columns, while a column vector has multiple rows and just one column. A square matrix is one where the number of rows equals the number of columns. If a matrix A has shape M by P, that means it has M rows and P columns. For example, this black and white image of an iris flower becomes a 2990 by 2714 matrix. It means it has almost like 3000 rows and almost like 3000 columns, where each entry represents the grayscale value of a pixel. We can use I to represent the row index of a matrix A. I increases from top to bottom, ranging from 1 to m. We can write the first row of matrix A as row vector A superscript 1, the second row as superscript 2, and so on and so forth. In this sense, a matrix can be seen as an ordered collection of row vectors. Now let's use K to represent the column index. K increases from left to right, ranging from 1 to P. We can write the first column of matrix A as column vector A subscript 1, and the second column as column vector A subscript 2, and so on. Similarly, you can view a matrix as an ordered collection of column vectors. The entry in row I and column K of matrix A is written as A subscript IK. For example, the entry in the first row and the first column is A11, and the entry in the second row, third column is A23. Every matrix has a special set of elements called main diagonal entries. They're the ones where the row and column indices are equal. The line connecting these elements are known as the main diagonal. Imagine each matrix entry as a square cell of equal size. Then the main diagonal is a 45-degree line stretching from the top left corner down to the bottom right. No matter the shape of the matrix, tall, thin, short and wide, square, row, or column vector, the main diagonal always exists. Adding two matrices, A and B, of the same shape, meaning adding their elements position by position. Scalar multiplication means multiplying every entry in the matrix by the same number.